We are on the part 2 of teaching calculus to kids. If you have not seen the previous video, please click on this link and watch it and then come over here. And once again, I remind you that this is for parents and teachers who wish to expose their kids to the basics of calculus. And this is the mind map of calculus. So there are two major branches of calculus. One is concept of function and another is rate of change. And as we progress, we will add more and more branches to it. And as I had shown last time, we are studying calculus using the example of trains going between a place on the foothills of Himalayas called Katihar and New Delhi. So this is the route. And so now we are taking time of one train. That train is Rajdhani Express. It leaves Katihar and reaches Delhi in 17 hours and 55 minutes. So I will go to the diagram. So here the train leaves and we call this 0, reaches Patna in 5.25 hours. So if you look at this plot, on this plot you see here, this is 5.25 and this is Patna. So the point is for Patna. And then the second point is Kanpur, and that it reaches over here 12:45 hours. And this is Kanpur, and this is Delhi, and it reaches in 17.55 hours. So what we have on the x-axis, we have time, and in this direction we have distance. So when we talk about the concept of function, let me choose a different color for the pen, a little brighter. So what we have here, we have distance as a function of time. So the way you look at it is that as you move through time, you are moving through distance, and the distance that you cover depends upon how much time has gone by. So for this train, Rajdhani Express, in 5.25 hours you reach a place called Patna. In 12.45 hours you reach a place called Kanpur, and in 17.55 hours you reach a place called Delhi. So at this point you should be able to teach your kids on how to plot time and distance and show the relationship that as you move through time, you're moving through distance. So this point is 200. Let me choose different color, black. So this point is 289 kilometers and 5.25 hours. And here the distance is now 849 kilometers. So as the time increased, it went from 5.25 hours to 12.45 hours. Distance increased from 289 to 849 kilometers. Similarly, as the time went to 17 hours 55 minutes, distance went to 1287 kilometers. So what you see here, as time increases, so does distance. So this is a very simple concept of function. Distance depends upon time. Now we will look at another train, and that train is called Mahananda Express. Let me go a little. So Mahananda Express reaches Patna in 6.40 hours, Kanpur in 17.30 hours, and Delhi in 27.55 hours. So now see what it looks like on the plot. So this is our Rajdhani Express. And this is Mahananda Express. So you see what's happening here is that Rajdhani reached Patna at this point in time, which is here. Mahananda Express took little longer. Similarly, Rajdhani reached Kanpur. This is Kanpur at this time. So let me write, this is Patna. This is Kanpur. This is also Kanpur. And this is Delhi. And this is Delhi. So you see, the blue line is for Rajdhani Express, and the orange line is for Mahananda Express. And you see that this curve, this line, is little closer to the time axis than Rajdhani Express. So this is Rajdhani Express is more steep compared to Mahananda Express. Now let me add a plane. So there is no plane, there is no airport in Katihar. So I am just assuming the time from Bagdogra. So say it takes 3 hours to reach from Katihar to Delhi. So now we have 3 plots. This is for a plane. This is for Rajdhani. And this is Mahananda. So when you look at the time, Rajdhani took 17.55 hours to reach Delhi. Plane took 3 hours. And Mahananda, let me take a look. Mahananda took 27.55 hours. And this tells you that it's the same distance. So distance. So this took 3 hours plane. Rajdhani took 17.55 hours and Mahananda took 27.55 hours. So now I want to ask you that we have three lines. Let me change the color. So line 1 so line 1 took 3 hours, and that's the plane. Line 2 took 17.55 hours, and this is Rajdhani. And line 3 took 27.55 hours, and this is Mahananda Express. So we can say it's very clear that this is 3, this is 2, this is 1. So which one is faster? So we can say faster plane is faster than Rajdhani, which is faster than Mahananda. So what is the relationship between this angle and this angle and this angle? So I'm introducing a new term here called slope. Let me choose color black. So this angle is slope. This is slope 1. This is slope 2. And this is slope 3. So slope 1 is the biggest in this, which is bigger than slope 2, which is bigger than slope 3. So what we can say that on a distance time plot, bigger the slope, faster is the vehicle. All right. So now I go back to this. Let me choose a color that we have not used before. And let me draw a train. Again, is going to Delhi. And I call this unknown train. Or let's give it a better name. Call it Tufan. There was a train. Tufan means storm. So this is slope of Tufan. So now we see that, let me drive here, slope of Tufan is greater than slope of Mahananda. I misspelled it. Mahananda. Slope of Tufan is less than slope of Rajdhani. And slope of Tufan is less than slope of the plane on this diagram. So what does it tell you? The speed of Tufan. What tells you that because this slope is greater than the slope of Mahananda, it must be moving faster than Mahananda. Because the slope is less than slope of Rajdhani, let me draw a line between let me choose a blue color. So because the slope of Tufan is less than the slope of Rajdhani, that means Tufan moves slower than Rajdhani. Similarly, slope of Tufan is less than slope of the plane. You can say that Tufan moves slower than the plane. So you see here the concepts that we have covered so far. We have seen how we can plot distance as a function of time. So this is Rajdhani Express. As time increases, you cover more distance for Rajdhani. Then we plotted another train, Mahananda, that takes longer to reach Delhi. And then we created a plot for a plane which gets to Delhi in 3 hours. And then we introduced the concept of slope, that in this distance time plot, bigger slope means faster speed, because we saw that plane reaches in 3 hours, Rajdhani in 17.55 hours, and Mahananda in 27.55 hours. Then we drew a line of a train that we don't know if it exists, this red line, and the slope of this train was bigger than the slope of Mahananda and less than the slope of Rajdhani and plane. And based on that, we deduce that this speed must be between the speed of Rajdhani and Mahananda. And we cover that over here. Now I want to introduce one last concept here, which is the concept of average speed. So I will bring up the plot of Rajdhani Express and then we'll look at it. So here is the plot of Rajdhani Express. This was it started from Okay, all right. So this is the plot of Rajdhani Express, and as we saw that it started from Katihar at this time at 5 point some hours. Let me use something darker. It reached Patna, and at this point, what is happening? It reached Kanpur, then it reached Delhi, and the total time it took was 17.55 hours. So you see that it's not a straight line. It's not a straight line. So the slope here, now we know what is slope, is different from here and here. Is because train does not move with a uniform speed between stations, because sometimes there are some spots where tracks are not good, so train has to move slowly. But we see that distance speed between Kanpur and Delhi is fairly similar. So we will draw a direct line between Katihar and Delhi. So this slope, this is average speed. So the train may be not moving at a constant speed, but when you draw a straight line, this is called average speed. So when you look at this diagram, you see that Mahananda moves at different speed between Katihar and Patna, Patna and Kanpur, Kanpur and Delhi. But the plane has a straight line here. So this is the concept of average speed. So let me write here this line shows average speed. All right. So going back to our mind map here, we looked at two things: function and rate of change. So we saw function, distance is a function of time, and we saw the slope is what tells us about rate of change. So if I give you an example of a mountain, that's where we hear most about slope. So I put a picture of a mountain. So this is what we are all very familiar with, this concept of slope. So this is slope. This is slope. So when the mountain is steep, we say that the slope is very high. So this concept of slope we are all very familiar with. It's harder to climb when slope is large. So coming back to the concept of slope. So here is the slope for mountain. Slope of mountain. And we have talked about slope of distance and time. So now let's have fun with this. This slope is a slope of horizontal versus vertical. So if I draw it here, so this slope tells you that how you are moving upwards as you're moving in the horizontal direction. So this is all for this this tutorial, and in fact, I should add one more thing to the mind map. So here is the mind map. So we have covered function, rate of change, and one more thing, plotting. So concept of function, concept of rate of change. So function was distance as a function of time. Rate of change is the slope. So higher slope meant faster. And plotting is that we were plotting distance and time. So that's all, and I look forward to your feedback. Thank you for your time.